per hour in the west direction with negligible water velocity. I don't know what that means. When you reach a certain point, you will encounter water flow with a velocity of 6.2 miles per hour in the north direction. So isn't that just asking magnitude and direction?
Yes, that would make sense.
So, okay. Let me find my notes.
So,
Okay, so finding the magnitude.
okay, so that'd be like your x and your y, that, or your a and your b, I guess. Like, would the coordinates be 3 and 6.2?
Speed is 3 miles per hour. Well, see, I don't know what velocity is though. If that, because your magnitude is speed, right? No, I don't know. Let me see.
Because if we it's like we can use that as like vectors. You know what I mean? Like we did in my you did in my math lab.
Yeah.
So if it was like the coordinates were 3 and 6.2. Again, I don't know if as for being A and B.
Okay.
Then it's you find the magnitude by, of course, the square root of a squared plus b squared. You know what I mean?
Yeah.
So it'd be the square root of 3 squared plus 6.2 squared. Again, I don't know if that's like how we're supposed to do it. So like I got the square root of 6.887 for my V, for my magnitude. But again, like, I don't know if that, or the square root, sorry, of 6.8.
Mm-hmm.
And again, I don't know if that.
So I'm just gonna draw like a little picture, kind of, I guess. Try to help me out with this. 3 miles per hour. Oh, it would help if I knew west and east, I guess. What does negligible water velocity mean? Do you know?
Yeah, meaning when he was swimming, he wasn't getting any like current back at him. You know what I mean? It was negligible. Like,
okay.
So like you don't have to worry about like, oh, like was the water,
Kind
how
of
strong
like
was the current?
that makes sense. So like the
Yeah.
resistance or whatever.
Yeah, exactly. The resistance. Yeah.
Okay. So when you reach a certain point, you'll encounter water flow. So, okay. So what if we just draw like a picture like this? Here, I'll show
I
you.
see. Okay.
So, and this is what we're looking for. Does that make sense? Am I showing
Yeah,
the
it
right
does.
thing? Sorry.
Yeah, I can see it. Yeah.
Okay.
So like a
So yeah, if we just use that, I think we'll be able to figure it all out because.
Yeah, that's true. Just find the hypotenuse.
Mm-hmm. So let's see. So v of x equals. Oh, hold on.
So yeah.
So if our Vx equals 3, don't we just work backwards? I don't know what I'm saying. 3 equals some magnitude cosine of some direction. That doesn't make sense. What is the resultant speed and direction? Okay, so, okay. So we have Hey, you're back. So this is just hard because we don't have an angle.
Yeah. So you can find the hypotenuse.
Yeah.
I really haven't really done a problem
Like
close to
this.
my homework or anything.
Uh-huh.
Just trying to look back on my math lab and see if I had done something like that, but it doesn't really seem like I have.
Yeah, I don't remember doing it either, so.
Yeah, like my only guess, like I said, was if those two speeds are supposed to be like, the A and the B, and that's how we find the R, but or the magnitude, sorry. But again, I mean, that could easily not be right.
Yeah, well, I was just kind of looking at that. Remember that horse example that we did a couple days
Yeah.
ago? I was kind of like doing stuff with that. The only
Uh-huh.
issue is we don't have like an angle given.
Yeah.
So it's hard to like figure out how to do that.
Yep.
Is there a way to get an angle with like two vectors lengths?
I mean, I don't think so. Well,
Uh,
sorry, the internet's slow.
Oh no, you're fine.
So I'm trying to see in a textbook. More clarity on it.
I don't know. I'm gonna start working on number 2 though, just because I need a break from that one.
Yeah. I'll see if I can get something in the textbook about it. And so you said you kind of knew how to do number 2.
So okay, it has a lot of like. Here, let me grab a piece of paper. A lot of like substitution and stuff.
Uh-huh.
So let's see. We have r equals 10 over 3 sine theta minus 7 cosine theta. Okay, so let's see what I did.
So would you start off by multiplying both sides by the
3.
denominator,
Yeah.
right?
Yeah. Yep.
So I'm just confused as far as you multiply. Is it just R? I
So
using the factoring with the R.
yeah, so like what I did is so you make it r times the whole denominator, right? To get
Okay.
the other side equal to 10. So then you do 3r sine theta
Oh, okay.
minus 7r cosine theta
Okay.
equals 10. And then you can, oh shoot, it's like, I have these written down somewhere. To convert, so x equals r cosine theta. So it would be, so since r sine theta, since we're just going to take the first part, so 3r sine theta would turn into 3y because y equals r sine theta. Does that make sense?
Yeah, it
Okay.
does.
So 3y minus 7x equals 10. So then, don't you just make it y equal to y? Is that how we do that?
That's
Okay.
what you want to do, yeah.
Yeah. So then, yeah, just add the 7x to the other side.
Yep. Then you divide everything by 3.
Mm-hmm. And that's how you get your answer.
Okay. So y equals 7/3 x.
Yeah.
over
Does that
3.
make sense?
Yeah, that does. And
Okay, cool.
like on my math lab, I was able to do it.
Yeah, it's easy once you have like all the substitution like equations and stuff.
Okay, that makes sense.
Yeah. All right, so then we can do the same thing with the other equation.
We just want to convert it to be polar, yeah.
Yeah.
Oh, sorry, we went. Yeah.
Sine over cosine is tangent? No.
Yeah.
Yes? Okay. So what did you come up with?
So I had notes on how to do it. I'm still trying to
Oh
get
no,
there.
you're good. You're good.
Are you done?
Sort of. I can like walk you through what I'm thinking.
Okay.
So we know that x squared plus y squared equals r squared, right?
Yeah.
So you convert that to r squared, and then you take the 9 times, change the y to r sine of theta, and then change x to r cosine of theta.
Okay.
And then
That makes so much sense because then it would just be tangent, right?
yeah, and it's nice because the 9, so like you
Wow.
can square root both sides right then and
Uh-huh.
get r equals 3 sine over cosine. Does that make sense?
Yeah, that does. Okay.
So you get just 3 tangent theta. I think that's the answer. That's what I'm thinking. But.
Yeah, that makes a lot of sense.
So. Okay. So we got those 2 done. 2 more left.
Yeah.
And then you have to leave here soon, don't you?
Yeah.
Yeah. And we can like both work on number 1, and like if we figure it out, we can just like text each other tonight and try to figure it out.
Yeah, because it's due at midnight tonight, right?
Yeah, and then I can make up like a like a paper of it and send it in.
Yeah, because I'll have time to work on it in like a couple hours, and I'll have like a while. So
Okay. Yeah, I will be able to work on it around 7 o'clock tonight.
Okay. Yeah, I'll just text you what I come up with, and
okay, cool. All right.
But as far as number 4, graph report coordinate 4 pi over 3. Okay.
When I did these on the my math lab assignment, I totally overthought it all. It's so easy though.
It's seriously not. Yeah, not that difficult. Name the other two polar coordinates that are located in the same place as 4 pi over 3.
Okay, so when we name two other ones,
Yeah, so we graph them and then we name them. So where was your point at?
I have it like in the third quadrant towards the bottom.
Okay. Why? Oh, yeah, sorry. I was thinking 3 pi over 4. Sorry.
Oh no, you're fine.
Oh, yeah, it is. You're right.
So how do we name two other? Do we just add 2 pi to that? Is that what we're saying?
Because so according to the question, that point where this is at isn't unique, and so there's two other points. There's two other coordinates that should have the exact same point, I guess. So that's how it's asking, like, what, you know what I mean? What are the other points that have the exact same location as that?
Okay.
As far as, I mean, I don't know.
Could it be like a degree? Does that make sense? Like,
Yeah, that would be probably right.
so if we did like, because I have an example
Uh-huh.
in my notes that says the point 1 comma negative pi over 2, which is like this point right here. Oh, you can't see that. It's like the first point on the y-axis that's negative.
Uh-huh.
It could be 1 comma negative pi over 2, or it could be negative 1 comma 450 degrees. That,
Negative 4.
yeah.
Okay.
So, I don't know. That was from the textbook, so.
Mm-hmm. So if we converted that over degrees, then it would work.
I'm guessing.
Okay.
Pi over 270. Couldn't it also be like negative pi over 3?
Negative pi over 3?
Yeah, 4 comma negative pi over 3.
That would be the third quadrant, wouldn't it?
What's that?
Because if it was negative pi over 3, it would be in the third quadrant, right?
Yeah, it would be the same thing as 4 pi over 3.
Yeah. And the 4 would remain
Yeah.
positive, though, right?
Yeah, that's what I'm thinking. And then we have I'm just kind of confused why it's negative 1 and 450 for this example.
Yeah.
Negative. Oh. Okay, I don't know how to explain how I got this, but I got -4, 420 degrees, 420 degrees.
420 degrees.
Yeah.
Would 420 degrees be in the third quadrant?
I think so. Let me go to the textbook quick.
Okay. I'm just trying to see if this works.
So we can actually do yeah, it's like adding 2 pi to it. So we can do 4 comma 4 pi over 3, which is what it actually is.
Yeah.
Then we can also do 4 comma negative pi over 3 because that's the opposite.
Yeah.
And then we can do something like 4 comma uh,
Put it into degrees.
we could do that, or we could just add like 2 pi to that.
Oh, okay.
So like we could do I can't, why is this not working? Pi over 3 times 2 pi. So we would do 6 pi over 3,
Uh-huh.
which would be 5 pi over 3. Because you take the pi over 3 times 2 pi over 1, you get 6 pi over 3, and then you subtract the pi
Yep.
over 3 that you get from the second one. Does that make sense?
Yeah, that does. Okay.
Okay, I'm glad.
Sweet.
The only issue is, wait. The only issue is that's 300 degrees.
That wouldn't be in the third.
Maybe it's 7 pi over 3. Oh yeah, because that's negative. So it's negative 6 pi over 3 minus pi over 3. So it'd be 7 pi over 3.
Oh, okay.
So yeah. Does that kind of make
Yeah,
sense?
that does.
Okay, cool.
Okay. But yeah, sorry, I'm already late, so I better go.
Yeah,
But
I'm so sorry.
no, it's fine because I needed to understand how to do that. So that makes sense though.
Awesome. So yeah, we'll just work
But
on problem 1 and text each other tonight or something.
okay, that sounds
Okay.
good.
All right. Good luck. Have a good day.
Okay.
Bye.
Yeah.